It's funny. We spend so much time and so much money on the ends of our tech chain.
Oh, yeah. The super powerful computer, the perfect 4K monitor.
Exactly. But we almost never think about the thing connecting them. I mean, a DisplayPort cable is just a cable, right?
Right, until it isn't. It works fine until you need to go more than, say, 15 feet.
And then what happens?
Then you hit what we call the digital cliff. It's not like analog where the ticket's a little fuzzy. With these high bandwidth signals, it works perfectly, or you just get nothing, black screen.
And that is a perfect lead-in to what we're looking at today. It's the Avenview FO-DP4K-300-EMIX-R.
That is a mouthful.
It is, but its job is super specific. It's a receiver that lets you push an uncompressed 4K video signal over distances that copper just, well, physically can't handle it.
Yeah, we're deep in the extension market here, and the key word you said is uncompressed. That's the whole mission.
Yeah.
How do you get a perfect pixel-for-pixel signal from here to, say, 300 meters away?
300 meters, I mean, that's almost 1,000 feet.
It's the length of 3 football fields.
You could have your computer in a basement server room and your display in a penthouse office.
And the user would never know. That's the goal. And you absolutely cannot do that with a standard copper cable.
Why not?
It's called attenuation, signal loss. The electrical resistance in the copper just kills the data over distance. This Avenview unit gets around that whole physics problem by basically swapping electrons for photons.
Oh, it's using fiber optics.
Exactly. It uses a single SC-terminated OM3 or OM4 fiber cable. Light doesn't care about electrical resistance, so it can carry that huge amount of data over a third of a kilometer with basically zero signal loss.
Okay, let's talk about that data, because 4K is a word that gets thrown around a lot. Looking at the specs, this isn't just, compressed YouTube 4K.
No, absolutely not. This is true 4K. That's 4096 by 2160. And the really crucial part, it's at a full 60 hertz refresh rate.
Which is the deal breaker. So many of the cheaper solutions, they cheat by compressing the signal or they drop the frame rate to 30 hertz.
And you can feel it. Your mouse cursor feels laggy, video looks choppy.
Yeah.
To do 60 hertz uncompressed, you need a massive data pipe. This thing supports HBR2, high bit rate too.
What does that mean in terms of speed?
It means it's processing 5.4 gigabits per second per lane.
Wait, so that's, what, over 21 gigabits of total throughput?
Precisely. It's fully compliant with DisplayPort 1.2a. It supports multi-stream transport so you can daisy-chain monitors, and it handles content protection. It's basically an invisible cable that can be 1,000 feet long.
Invisible is a good word because the actual box is incredibly small.
Oh, yeah.
I'm looking at the dimensions here. It's about 3 inches by 2 inches. It's like a deck of cards.
And it weighs, what, 1.5 pounds? The whole idea is you mount it on the back of a monitor or hide it in a rack. It's designed to just vanish into the infrastructure.
The price tag, though, is pretty visible. List price is around $1,800.
And that's just for the receiver, the RX unit.
So you still need the sender unit on the other end.
That's right.
So you're looking at, like, close to $4,000 to replace a cable.
It sounds totally insane until you think about who this is for. This isn't for your gaming PC.
Okay.
This is for an operating room where the surgeon needs to see a live feed from an MRI machine that's in a completely different shielded room. It's for his stadium control center.
Mission critical stuff.
Exactly. You're not paying for the box. You're paying for the guarantee that the screen will never, ever go black because of some electrical interference in the walls.
So it's like an insurance policy for your pixels?
That's a perfect way to put it. It just shows how much heavy engineering is happening in the background, We all demand 4K, 8K, high refresh rates.
Right. We just expect it to work.
But we forget that all that data has a kind of digital mass, and moving it takes serious work.
And as we're all looking towards 8K and beyond, that mass is just going to get heavier and heavier.
It really makes you wonder, we keep pushing for more pixels on the screen, but are we about to hit the physical limits of the walls and floors that have to carry that signal? At what point does the cost of moving all that data become more than the value we get from the extra resolution?
That's a very expensive question to think about. That's our deep dive on Avenview's fiber optic solution. Thanks for listening.